Hello, everyone. My name is Jasmin Bender. I am a high school biology teacher in Michigan, and this is my technical presentation for PCM 301 that discusses how to create a science lesson according to NGSS standards. I'm going to start off with a question today. Have you ever wondered how science teachers design lessons that don't just focus on memorization, but actually get students to dive deep and use inquiry or curiosity to solve real world problems? Today I'm going to show you how to create an NGSS aligned lesson plan, and we're going to cover three main points. First is an overview of NGSS and its three dimensions. Second, the essential components of an NGSS lesson plan. And third, a step-by-step process of how to create one yourself. Finally, I'm going to show you an example of a lesson plan that I created for my own high school biology classroom. To start off with an NGSS overview, you have to adequately understand what this is to understand what NGSS is all about. NGSS stands for Next Generation Science Standards, and unlike traditional standards that often emphasize memorization, NGSS is built around the three dimensions that work together. The first one is Science and Engineering Practices, or SEPs, and this is what scientists do, like ask questions, design experiments, and analyze data. The second one is cross-cutting concepts. So these are the big ideas that link all areas of science, like cause and effect or patterns. And having students recognize these in processes or experiments is a great way to build on our inquiry. And the last one is disciplinary core ideas. And this is what the actual science content, such as cell biology, ecosystems, or physics. By combining all three of these dimensions, NGSS encourages students to apply science knowledge through practice or modeling. Instead of just answering what is photosynthesis, students may be able to dive into why do some plants thrive in shaded areas versus full sunlight. And this shift makes science learning more authentic and prepares students for both college and real-world problem solving. To start off with some lesson planning components, when planning, teachers have to include a learning objective. So this connects directly to a PE, or a performance expectation, from NGSS. Then they get into engagement. So this is often through a real world phenomenon or a driving question. A lot of times we will use the something stinks in here phenomena, and we will discuss how particles move across a gradient or diffuse through the air. Then we get into exploration. So where can students investigate, experiment, or use models to find answers? We then do an explanation. So how do students connect their findings to the science concepts that we are learning about? And then elaboration and evaluation. This is how we extend their learning a little bit further and check for mastery of the subject. This structure is often called the 5E model, and this aligns naturally with NGSS because it keeps students at the center of the learning process. So our step-by-step process is to first choose a performance expectation, or that standard. Then you're going to identify a phenomena. So one that we use was does exercise cause your heart rate to increase? Number 3 would be to plan activities that connect the three dimensions together and how we're going to build the students' learning upon this. Then you're going to design assessments. So these could be formative assessments, exit tickets, a task, anything hands-on. I really enjoy hands-on modeling for my students. And then finally, the last and probably most important step is how are you going to reflect and revise on the lesson plan that you just did. You need to evaluate what worked and what didn't. And sometimes for me, this is from not just year to year, but class to class. Something that worked in my 4th hour might not work for my 7th hour. And that's okay. You just need to learn from it and build upon that. And using this cycle ensures that the lessons are not only aligned with NGSS, but are also responsive to our students' needs. So an example lesson plan I used the second high school life science standard from molecules to organisms, structures and processes. This standard says to plan and conduct an investigation to provide evidence that feedback mechanisms maintain homeostasis. So we could use the phenomena, how does a simple paper cut trigger a whole body healing response? We have activities that students can do, diagrams and models, using case studies to compare other examples of homeostasis to this one that we're specifically talking about. And then that assessment piece is, like I said before, I love to use hands-on models, kind of touch those visual learners, those audio learners, kids that like hands-on, but also include maybe an exit slip to also hit the point with the kids who like to use paper and pencil still. So in conclusion, we covered our 3 key ideas, which are NGSS is built on 3 dimensions: practices, cross-cutting concepts, and core ideas. We talked about that a strong NGSS lesson includes clear objectives, engagement, exploration, explanation, elaboration, and evaluation. And then we walk through the 5 steps to creating our own NGSS aligned lesson planning, from choosing performance expectations to reflect on the lesson. When teachers use NGSS in lesson planning, they transform the classroom into a space where kids don't just learn science and facts, but they actually become scientists. This is my list of references, and thank you for your time and happy lesson planning.